So again, morning everyone. So let's get started with the today's session, and we'll continue with the revision of topic of current electricity. Some part we did yesterday, and we'll continue from there. We have not done about power consumption part, and I think as far as the power consumption goes, formula all of you should remember. So I'm not even writing the formula. Let's look at some simpler application of questions related to power consumption. And this is a common kind of question. Just assume that two bulbs rated. This is typically all electrical appliances will have a rating, power, and what voltage it should be operated at. So this power consumption is at when this is connected to this voltage. Okay. So the two bulbs, one is 500 watts, another is 150 watts. For simplicity, I have taken 200 volts. They are connected in series across a 400 volts of power supply. What is the power consumption in each bulb? Okay, so before we get started, what we have to keep in mind, these are things we have to keep in mind in case of power consumption. So whenever any resistance or any electrical appliance is connected in parallel, which typically happens in case of home supply, everything is connected in parallel, everything is connected across a voltage of 220 or whatever, 220 to 240. So when they're connected across in parallel, V same. In that case, power consumption, since V same, which formula used for power consumption? There are three formulas of power consumption. If V same, we'll use the formula V square by R. So what you notice, the one which have higher power, the appliances with low resistance will have higher power consumption. Or we can say the power consumption is proportional to 1 by R. But when they are connected in series, then potential is not equal, current is equal. And in that case, I will use power is equal to I square R. So when the current is same, power becomes proportional to resistance. So the resistance which consumes more power when connected in parallel, if it is connected in series, it will consume less power. It reverses. So let's try and solve this question. One way of solving this question, okay. So they are connected across 400 volt supply. From this information, we can easily calculate the resistance of each. So what will the first bulb? What is the resistance of 50 bulb? We can calculate resistance of this also. We can calculate resistance of this also. And the one which has higher wattage will have lower resistance. So if we can easily calculate, if this resistance is R, this will be equal to 3R. The resistance is inversely proportional, the power consumption is proportional to R. So when two bulbs are connected, it will be like this. Very quickly, and this you can calculate in more detailed way also. But let's understand, this bulb also is nothing but resistance. So this is 50 watt bulb. 50 watt bulb is actually equal to what? Is equal to resistance is 3R. And other one is 150 watt bulb. And this resistance is R. And they are connected across what potential difference? They are connected across 400 volts. If they are connected across 400 volts, this potential difference gets divided or shared between two bulbs which are connected in series. And this will be in proportion of the resistance. So what will happen? It gets divided in the ratio of 3:1. So this potential will be equal to 300 volts and this will be 100 volts. So what happens for this bulb compared to rated volts? The voltage has become half. Resistance has remained same. If voltage becomes half, the power consumption here, this will have power consumption 1/4 of its real power consumption, rated power consumption. Whereas in this case, what you notice here, see, it is rated at 50 watts at 200 volts. The voltage has become 1.5 times. Hence, the power consumption become 2.25 times. So this power consumption will be 2.5 times of 50 watts. So that's another way we can solve, and hence since the power consumption is more than the rated power consumption, this will overheat and it may fail, it may fuse. So this is something, this question to make you understand what happens if you connect in parallel and what happens if you connect in series. Such question can easily be solved. Let's look at one more. Say in this circuit, 5 ohm resistance develops this particular joules per second. This is watts only. So this one is a particular power consumption. This power consumption is given here due to current flowing through it. What is power developed across this? This also is a fairly easy question. You can easily solve. So you can easily notice from here, if this current, if I take this current as I, this is 15 volt ohms and this 5 ohms. So the current will be inversely proportional to resistance. So this will be 3I. If this I will be equal to 4I. And I can calculate ratio of power consumption, and since power consumption is given, I can easily solve. And this also you can do on your own. You can find your answer in the work session or later on. Let's look at this question, which is slightly more tricky. And sometimes people get confused. What should the value of resistance R so that power dissipated in 2 ohm is maximum? I want to maximize power consumption in this resistance. This is not similar to what we had done earlier. We had done a case where the resistance in which power consumption was to be maximized, the resistance itself can be varied. Here, power consumption in a resistance is to be maximized by varying some other resistance. So understand the difference between the two. So how do you solve in this case? See, in this case, thinking what would maximize power consumption in this resistance? Total voltage is 12 volts, and this is being shared in 2 parts. One part is the resistance connected between these 2 points, and second part is this. So what we understand, for a given resistance, power consumption in this will be maximum when the potential difference across 2 ohm is maximum. So when is power consumption maximum? P will be maximum. P in 2 ohm will be maximum when it gets when it gets largest possible share of potential 12 volts. पैसे रखे नहीं, हम रखते थोड़ी पैसे, देखते लाके देते बाबा को नहीं, अभी लाकर लाके देते. It gets largest share of 12 volts. And what is the, when would you get largest share of potential, largest share of this 12 volts? When this resistance becomes the smallest. So what has to happen? The power consumption is 2 ohm will be maximum when resistance between RAB becomes minimum. So what has the value of R to make the resistance between A and B to be minimum? How do you make the resistance minimum? What is the value of R? How should I adjust the value of R so that resistance between point A and B becomes minimum?
0.
R has to be equal to 0. So this is slightly different question, and I hope you understand difference between 2 types of question what we come across. So this is not something we equate to resistances. There are some questions on design of a fuse. What is the role of the fuse? I'll quickly tell. Role of the fuse is to limit the amount of current which flows into the building. What should fuse be designed? Fuse should be designed to have a maximum value of I. The maximum value of I should be equal to current when all equipments are on. So basically, even if whatever equipments are connected at home, if all are active, all are in use. So basically, if we add up current in all appliances and whatever sum we come to, that's a capacity of fuse we designed for. So all you need to do here, so assuming that all are on. So what does it mean? If the current drawn is greater than this value, it means current is not being drawn by the appliances, it is being drawn, extra current is drawn because of short circuit, and thus indicates failure, and that's why fuse will not allow more current than this to flow. Because ideally what should happen when all the appliances are connected, that's the current drawn. And you should understand, B remaining same, power consumption, as the power consumption keeps increasing, I will keep increasing. I will be the sum of current drawn by all appliances put together. So calculate current drawn by each of them, sum it up. That's the capacity of fuse which has to be designed. So fuse current is equal to sum of current drawn by all appliances in on condition. Then we come to something called RC circuit. Let's quickly understand. I'm not going to derivation. Derivation of RC circuit is pretty simple. So here, when we connect a capacitor through a resistor, and this resistor is not necessarily an external resistor, this R may include internal resistance of the battery, resistance of the lead wire, as well as any resistance connected. So all equivalent resistance in the circuit is reflected in this R. So this R includes all the resistance in the loop, equivalent resistance in the loop. So when we connect, this will start charging. So in terms of understanding RC circuit, in terms of Kirchhoff loop rule, this EMF applied or potential difference applied gets shared between resistance and the capacitor. So if you write the equation, so what is this E equal to? So this is our understanding. That's how we should interpret. E is equal to potential difference across VR plus VC. And this will keep changing. This ratio, as the charge on the capacitor keeps increasing, this is what charging means. So what will happen as soon as you connect, this will keep increasing in the charging process, and automatically this will keep decreasing. Why is VR decreasing? Current will keep decreasing. So that's what happens. So when we current is varying with time, so we can do only at an instantaneous value. At an instance, we write those values. So at an instant, what is the equation we write here? E is equal to, at an instant, current is, we are taking some random time t, current is I, so VR is equal to IR, and at that instance, charge is Q here. So this becomes Q by C. And what is Q, I equal to? I is equal to rate at which charge is changing. Using this, we arrive at this expression. And this is the charge at any time t. And what is the term we call? This term is called T, tau is called time constant. Reason it is called time constant, it has same dimension as time. And what is tau equal to? Tau is equal to R into C. What is R here? Resultant R. And if there are two capacitors, we can take resultant capacitance also. So one is understanding this charge, this equation. And this equation we can understand in terms of graph. And so what will happen as the graph also with time, what we notice here, the charge on the capacitor keeps increasing. But what you notice here, the slope, this is what is there on the y-axis, this is charge. Okay. When you look at the slope keeps decreasing. What does slope indicate here? Slope is keeps decreasing here, the slope has become 0. So if you have QT graph, what is the slope of tangent any point will indicate? Slope indicates dy by dx. Here in y-axis we have q and x-axis we have t. So the slope of the tangent will indicate what? dq by dt. The slope indicates value of current. And if we draw the current, current is something like this. Current comes like this. And what we indicate here, at time is equal to 1 time constant, it acquires a charge equal to 0.63 of the final charge. So there are some questions which are direct application of the formula, which is okay, we can easily solve. And what we find here, I think last time we did, in about 4 to 5 time constant, it acquires a charge which is more than 99%. So though theoretically it will take infinite time, but a fairly large proportion of final charge is acquired in rather short time interval. Okay, so time constant. Charge at time t, what is the charge, is equal to time equal to 1 time constant. Okay, and yeah, other way to define tau is okay, equal to time it would take if initial rate of charging is continued. So if I draw a tangent at time t is equal to 0, this will meet at time is equal to t naught. That's the last statement means. Okay, so this is something time is RC. Now let's try and understand. There are some questions which are typical application of formula, which is okay. This is something you can substitute and find. Let's see. Suppose we have the circuit, and this is my graph. It looks like for R into R and C. What will happen if I double the resistance? If in place of R, I make R as 2R and keep the capacitance same. How would the graph change? Can you all think in your mind, how would the graph change if I change one of those two? I double the resistance, keeping the capacitor same. Okay, so when we look at this graph, what should the graph look like? And this is the initial graph. So can we draw a new graph if R is converted to R and C is equal to C? What changes will happen? Can we draw and drive? So here, will the final charge, what does this line indicate? This indicates the final charge on the capacitor. Final charge on the capacitor, does it depend on value of R? We have doubled R. So what will happen? The final charge, this final charge is equal to E into C. We have not changed C. It means curve will reach the same final value. So when in this case, so if we take this variation here,
it will get stretched, sir.
Yeah, but only thing what will happen in this case, what happened? The tau is equal to new tau, or tau 1 is equal to twice the tau. So what it means, it will acquire the same final charge, but now to acquire 0.60 times of the final charge, earlier it was taken time t naught, now it will take time twice of that. That's what it means. It has become 2 tau. So what is the shape of the graph? If I draw the shape of the graph, it will pass through this point. And finally, what will happen? Finally, end of this, it will end up attaching the same thing. Similar way, let's try and understand what will happen if I keep R as same now and C as C by 2. if we halve the capacitor. Okay, so what will happen in this case? The final charge itself will change. So what will happen? The final charge will not be EC, final charge will be equal to EC by 2. So it will reach this curve, and here also, what is the time this will become EC by 2? So what is the time it will take to acquire 63% of the final charge?
Will be tau by 2.
So it will be tau by 2. So if this is the where it will acquire half the charge at not time, that T naught, it will acquire at a time T naught by 2. So we should understand how to use this formula. And the current is, what is the current? If Q is given, we can find the current. So this indicates final charge E into C. And we can calculate current is equal to dQ by dt. What is the current expression comes to? In this case, if you differentiate, current comes to equal to what? I is equal to, you can write it will keep on decreasing. I is equal to I naught e raised to power minus t by tau. And this is the initial current. It will keep decreasing. What is I naught equal to? Maximum value of current. Maximum value of current will be equal to E by R.
E by R.
Yeah. So that's what we need to understand in case of charging circuit, and discharging circuit also similar way. So let's look at some simple application of this. And so what is the final charge on the capacitor? So whenever we talk about find the charge on the capacitor, this is in a steady state. See, whenever time is not mentioned, it means steady state. Steady state also can be stated as after a long time. After a long time, what will happen? After a long time, whenever the time period is sufficiently long, capacitor will get fully charged. It means no more charge is getting added. If no more charge is getting added, it means current in this branch will be 0. This will have 0. So that's what it means. The long charge, the charge on capacitor not changing. If charge on the capacitor is not changing, it means the lead wire will not have any current flowing through it. Or we can say the capacitor behaves as if, so lead wires to capacitor have no current. No current, which implies that after a long time, C behaves like open circuit. I hope all of you recall what does open circuit mean. Okay. So this is something, key points what you need to remember. So if you have to find charge, so in this case, what we assume, this part, no current will flow. We can as well remove this part. Okay. So how the current will flow in the circuit in a steady state, this branch, no current will flow. So whatever current starts from battery, this is the way the current flow will take place. If the current flow is taking place, what would the charge? So potential difference across the capacitor would be same as potential difference across these 2 points the capacitor is connected. So potential of the capacitor will be equal to VAB. That will be potential. And so what is potential per potential capacitor? That concept we can use, and we can easily find the value of charge. So potential here will be 1/3 of the 2 by 3 volts has to be equal to Q by C. Okay. Similar way, let's try and look at this. This is a circuit shown. It's shown what we notice here. First thing is a steady state. A steady state means the charge on the capacitor is not changing. It means this particular branch has no current flowing through. Okay, so current is not flowing in this branch. What we need to calculate? We need to calculate the energy stored in the capacitor. What is the energy stored? If I can find out, or other way I can find out, if I can find out potential difference between point and P and Q, I can find the energy stored. So I will start with this. What I need to calculate? I need to calculate the energy stored. What is energy stored in the capacitor equal to? We can write in 3 forms. You can write as Q square by 2C or 1 by 2 CV square. Okay, so here C is given. So if I can find value of potential difference across the capacitor, I can find out energy stored. So basically what I need to find, I need to find VPQ. What is the potential difference between 2 points? And how do you find VPQ? I can use Kirchhoff law. So basically what we do, we travel from where to where? Travel from P to Q along any path. And if we write potential increase and decrease, we can find. So let's choose which path we can choose. Here, this path we don't know. So path I will choose from P to Q. Let's choose this path here. Okay. So that's what we do here. So the circuit also, basically we can remove this part here. This part is removed, the rest of the circuit is left, and we can easily calculate. So what is from here to here? This value 2 ampere, 1 ampere is given. It means this current is equal to 3 amps. This also is 3 amps. And what is given here? This is 1 and this is 2. It means this also has to be equal to 1 ampere. So along the path, everywhere resistance and current is known, I can find potential difference. And once I can find potential difference, I can find the energy stored. This is what we do in case of energy state. And the key point here in energy state is steady state. No current in the wire connecting to the capacitor, or lead wires to capacitor will have no current. Okay, this question, a capacitor typical circuit is connected to R. Find the maximum rate at which the energy is stored in the capacitor. Yeah, we know as we capacitor keeps charging, energy, what is energy stored in the capacitor? Energy stored, we can write in multiple forms. Energy stored in the capacitor is equal to, I can write as Q square by 2C. So what happened during the charging process, as Q keeps increasing, if I use the term energy as U also keeps on increasing. It means I am storing more and more energy, but in order to be rate at which energy is stored may not remain constant. So what is the rate at which energy is getting stored? This energy is stored. So rate at which energy is stored, how do you find rate at which time rate at which energy is stored? What would that be equal to? Du by dt. And rate of energy will have same unit as power. That will be equal to du by dt. So what would du by dt leads to? It leads to du by dt if it is Q by C into dq by dt. So what is this equal to? It is equal to Q by C into dq by dt. Let's try and understand what will happen to rate of the energy stored. What does this term indicate? This term indicates current. And we know the current with time keeps on decreasing. We already know the current shape is something like this. It is exponential decay. What is this value indicates? It indicates potential of the capacitor. Is it not? So what the charge keeps going is, what is happening? There are two terms. It's a product of two things. One of them is increasing and other of them is decreasing. So it is not a continuously increasing or decreasing function. That's why it may reach a maximum value. And what is the unit? This is potential, this is current. So this is like VI, which makes sense, is power. Okay, so can we write this value? What is Q by C equal to? So at particular time T, we can write what is Q by C equal to. So Q by C, what is charge at time C? It is CB by C into 1 minus e raised to power minus T by tau. And what is current equal to? Current is equal to, is given V or EMF E by R, e raised to power minus T by tau. So that's the expression here. Okay, and of course it becomes equal to V square by R, or sorry, you can this also write, you can write as E. It becomes equal to E square by R, which makes sense. Unit has to be unit of power, rate at which energy is stored, e raised to power minus T by tau minus e raised to power minus 2T by tau. But this is rate at which energy is stored. We have to find maximum rate. For maximum rate of energy stored, what we need to do now?
Du by dt equals to 0.
0. Not du by dt is equal to 0. Maximum rate of energy stored is equal to dp by dt is equal to 0. So this gives you a rate at which energy is stored, and this rate is varying. I have to find when does the rate become maximum, dp by dt. So I have to again differentiate this term, equate to 0, and I find rate becomes 0 when capacitors acquires. You can do that derivation, you can do that part, all of you can calculate. When capacitor acquires half the final charge. Thus the time, the rate at which energy is stored is maximum. When capacitor acquires half the final charge. Or you're saying at that particular instance, when the rate at which energy is stored is maximum, when this term is equal to E by 2. So potential at that instance, potential of the battery is equally shared across the resistor and the capacitor. That's the time when rate at which energy stored is maximum, and we can easily calculate. In that case, we can calculate what is the maximum rate. So once we find the charge, we substitute value of Q and I, we can find the rate at which energy stored is maximum. This question also I'm leaving it. All of you, this is application of it. So some of the questions is part of assignment today, and you can, it's a mathematical expression. Put those values, so you can find an answer. Let's look at this question. So let's try to take a minute, try to understand here. Find the potential difference between which 2 points. I want to find this question. We need to find potential difference between this point and this point. In which state? Steady state. So let's see how do we find potential difference here. So what is my scheme to find potential difference? To find potential difference, but basically I need to travel from A to B to find potential difference. As we travel from A to B, we know as we cross capacitor, potential changes. I need to know the charge and the potential difference across the capacitor. And if in the path there's any resistance, I should know the current in the resistor. That's how it. So whenever we have to find potential difference, first thing I need to think is to find potential difference. We need to know PD across capacitors in the path, and we also need to know the current in the resistance across the path. That's what we need to know. So let's say how would we calculate here? How would the current flow? So as we flow from here, see this in a steady state, the lead wire, the charge on this capacitor is not changing, so this part will have no current, and this also is not changing, so this will have no current. And this also will not change. If these 2 branches have no current, it means this also will have no current. From junction, if these 2 branches do not have current, even this also will not have current. So what will happen when a steady state, no current will flow? So this question is a little peculiar question. No current flow in a steady state. So if no current flow, is there any potential drop across this resistor? No potential drop across this resistor, current is 0. And this current also no potential drop. So no current anywhere in the resistor. If there's no current flowing, we can as well remove. It becomes like a capacitor circuit. So it is a typical capacitor circuit, and we can find capacitor circuit. How do you find potential difference? You should know. And if we can apply that one, we can find potential difference between point A and B. Okay, so this becomes point. You can do that. You can this also you can try and solve. But we can remove this resistance and we redraw the circuit and find the potential difference between point A and B. That shouldn't be too difficult. You redraw the circuit. How many unique potential points? In the circuit, there are only 3 unique potential points, A, C, and B. So we can redraw. It is something like this. A, point C, in between point B. And this is how the battery is connected. And the resistors will have no meaning. The resistors potential drop is not there. So entire potential drop from this potential difference between this point and this point is 100 volts. So how do we draw? This is connected between A and B, 3 ohms. This 3 microfarad. This is connected A and B. How is this connected? This also is connected across point A and B. So this is 3 in parallel. How is this 1 microfarad? It is connected is across A and C. So this one is across like this. And these 2 are connected between B and C. So this is what the circuit is. And finding potential difference is fairly easy now between point A and B. Okay, this is 1, 1. So this becomes 6 and 2, and you can easily get that value. Okay. This is a slightly more complex question in RC circuits are those where capacitor has some initial charge. Okay, so let's say there are 2 capacitors connected, there's no battery here. One of the capacitor has some initial charge plus Q. So how we need to find the charge on the second capacitor as function of time. And with the help of this example, we'll also try and understand what happens when a capacitor is connected to a circuit with some initial charge. Okay. So in this case also, what will happen here? See, as soon as we connect, there's a potential difference between this point and this point. So of course the charge will flow. So current will start flowing in this fashion. If current is start flowing in this direction, this will receive some positive charge. And of course the charge flow will be like this. So whatever positive charge, this will have negative charge. So as soon as we connect, this is how the charge will start flowing. And let's say at certain point of time, if this charge is become plus Q, and of course this is minus Q, at that instance current is I here. If this charge plus Q, these two plates put together, they form an isolated system. So if this has acquired charge plus Q, it must have come from here. The charge on the positive plate will become equal to plus Q minus Q. This charge on this plate. So this is at a time t. So can we write again Kirchhoff law equation here? Well, how do you like the Kirchhoff law equation from here to here? Sorry, this is plus what I've written. So if I move from here and I can write Kirchhoff law. You apply Kirchhoff loop rule. What with this is an instance, the Kirchhoff loop rule will be like this. So if we start from here, Q by C. If I go, I think I have written the equation starting from here, going this direction. So this is the equation. And once we have differential equation, we can solve it. It comes something like this. Let's try and understand if this is something like this. And if I differentiate, current term comes something like this. Let's try and understand few things from here. What are the few things we understand? What is the time constant in this equation here? Can we identify the time constant in this equation? The time constant in the denominator term is called time constant. So in this particular case, for this kind of arrangement where there are two capacitors C and C are connected, the time constant is equal to tau is equal to RC by 2. Do you understand the reason why it is RC by 2? Yeah, these two capacitors, how are they connected? They're connected in series. So we can take equal capacitor as C by 2. That's why tau becomes RC by 2. Other thing what we notice here, what is the maximum? If I differentiate, I will get the value of current. So what is the maximum value of current, which many times uses I naught, is equal to Q by RC. And what is this Q by RC? I can write as V by R. What is V here? Potential difference across the capacitor. So we can think of time constant as RC by 2. So initially, as soon as you connect, this one is a capacitor also, you can think of capacitor as a battery of varying potential. So as soon as we connect, the potential difference is equal to E here. This potential difference initially has no charge, it has 0 value, and the resistance is R. So as soon as it's connected, what is the current which will flow? Initial current will be equal to E by R. E is equal to Q by C. That's the value of current what we get here. So this is something, these are not very common type of question, but if you need to solve a question which involves some initial charge on the capacitor, these are the points what you need to keep in mind. Okay, and this is a question again to refresh your memory. This question we had done last time. All of you read this question and try to figure out how to find the right answer. So I'll give you a minute. All of you read the question carefully and think of way to solve this question. So anybody would like to explain how to solve this question? Bhagyashree, can you answer this one?
So in the graph, in the both cases, they're starting from a constant point, which is log I.
Yes, perfect. So what we notice here, both the cases, the common point. So what does this indicate? They start from the common point in what? Initial currents are equal. Initial current equal. And what is the initial current? So if I write this as V dash, and this is R dash, and this is C dash. But we know two of them are same, only one is different. That's what it says. If current is same, what does it mean? It is means V by R is equal to V dash by R dash. Okay, so it means can one of them be different and still the ratio be equal? So this implies both V and R are not changed. Both V and R are not changed. Because by changing one, this ratio cannot be equal. So both of V and R are not changed. It implies only C is changed. So Shravani, can you tell me whether C is increased or decreased and why? First thing from this point we figure out. Can you tell me why? What happens to C? Whether C is increased?
C
So
will increase, sir.
why?
Uh, like 1 by RC1 is slope 1 is greater than slope 2, right? Sir?
Slope 1 is greater than slope 2. So basically, okay. So what we notice here, the second thing what we notice here,
1 is
slope
more
1,
steeper than
no,
2.
slope 1 is greater than slope 2. So what does it mean?
Y-intercepts are equal.
Okay, so basically, so the slope are more steeper. So what does it mean? Current drops more rapidly in which case? So if I take particular time, which will have more current? The second one will have more current. First one will have less current. Okay. So basically, current drops more rapidly in which case? In first case. What does this imply? Why current is dropping more rapidly? But time constant is more, it takes more time to drop. If time constant is less, it takes less time to drop. Or other way also, if I draw something like this, which is taking more time, this is taking more time for current to drop. Why it is taking more time for same drop in current? Because the time constant for second case is more. Why the second case time constant is more? Time constant product of RC, R being same, the time constant second case will more only when C dash is greater than C. So C is increased. Okay, some graph question also we should know. Let's come to this question here. Initially C is open and capacitors initially uncharged. And this also fairly simple question. All such questions are based on what? We can solve, we can draw two circuits. One at t is equal to soon after switch is closed and other is t tending to infinity. How do you draw soon after switch is closed? As soon as the switch is closed, capacitors offer this particular point, capacitors can be shorted. C can be shorted. It offers zero resistance. This can be shorted. And second case, after a long time, C behaves like an open circuit. So what will happen? T is equal to 0. If I have to draw a curve, the T is equal to 0, this also becomes shorted and this becomes shorted. Thus T is equal to 0. So moment this gets shorted here, so this point one, this point potential difference is 0. If this point potential difference from here to here is 0 also, no current will flow through here. No current will flow through here. So whatever current comes through, this is the path at T is equal to 0. Path of current will be like this. And at T is equal to infinity, this behaves like an open circuit. This behaves like an open circuit. So at T infinity, what would be the path of the current flow? The path of the current flow at T to infinity will be something like this. It will flow like this. That's the part we need to understand. So this is T is equal to 0. In between it will flow through both. And based on this, we can easily solve this question. Something like this. Charge is stored in the capacitor. This is also a fairly easy question. To charge is stored, we need to find the potential difference across these 2 points. That will determine the charge on C1. Potential difference across these 2 points will determine the charge on C2. And for simplicity, if I assume these two have zero potential, so here what will the potential drop in the ratio of 1:2:3? If this is zero potential, this will be 60 volts. This would be 100 volts, and this point will be 120 volts. Similar way, if I do here also, at this point also will be 60 volts, this will be 80 volts, and this will be 120 volts. So what I notice here the potential difference is equal to 20, here potential difference is 0. So C1 will have a charge, so that's what we can easily find. Capacitor C2 will not have any charge. So that's a way to solve such questions.